Welcome to the Department of Healthcare Access and Information, or HCI, formerly OSHPD, PIN 70 Electrical Overcurrent Protective Device Coordination presentation brought to you by the Building Standards Unit here at HCI. During today's presentation, we'll be going over the purpose of electrical coordination, overview of code requirements, frequently asked questions, HCI plan review expectations as described in PIN 70, some examples, and coordinating or submitting coordination studies to HCI. If you haven't done so already, feel free to download the PDF documents in the handout section of the go-to handouts, where you will find today's presentation in PDF, and you'll also find PIN 70 electrical coordination document for your use. You will be here for about an hour and a half presentation with some question and answer. You're all going to be muted during the presentation, but you'll have an opportunity to raise your hand and ask questions at the end of each section of the presentation. So we'll go ahead and be able to have a dialogue with you if you have a question. And if you haven't done this already, there's a little hand icon next to your name. Click on the hand icon. We'll see your hand raised. We'll be able to unmute you so you can unmute yourself and we can hear from you and hear your question. If you do have a question about this presentation, click your hand or type your question into the questions section of the go-to section in the of that toolbox, and we'll be able to read the question and read it out loud, and maybe someone else has the same question. But if you do have a specific question to your project, so related something that's very unique, feel free to send us an email over to regsunit@hci.ca.gov. Again, that's regsunit@hci.ca.gov. If you experience transmission difficulties, please log out and log back in using the same login information that was sent to you by the go-to software when you registered for the presentation. So today for presenters, we have Mr. Bill Gao, which is a senior electrical engineer here at HCI, and we have Mr. Jamie Schnick, senior electrical engineer, that's going to be in the background helping answer questions throughout the presentation. So Bill, if you're there, I hand the presentation over to you.
Hello, everyone. Again, I'm Bill Gao, and I work for HCI as the senior electrical engineer in the Building Standard Unit. I also have Jamie Schnick, who also helps me out with the Building Standard Unit, and will be taking over the Building Standard Unit responsibility in April. So let's look at the agenda. We're going to cover the purpose of electrical coordination, a quick overview of the code requirements, frequently asked questions, HCI PIN 70 plan review expectations. We'll look at some examples from PIN 70, and this last one is really important, and it's submitting coordination studies to HCI. So let's take a look at purpose of coordination. So what's the purpose of electrical coordination? Well, electrical coordination is a protection method for selecting and configuring circuit breakers and fuses in an electrical system to localize outages caused by an overcurrent condition. When you do it correctly, the outage is localized to the nearest overcurrent protection device upstream. All other overcurrent protection upstream of this device will remain closed. So let's look at a picture. So on the right, on the left, we have a coordinated system. We have this unit number 5. There's a short in the cable going to it. It opens breaker F. And as you see, breaker A does not open because F is coordinated with A. The remaining pieces of equipment, 1 through 4, stay energized. In a non-coordinated electrical system, a fault on this feeder will open A and F, and will lose power to the other equipment connected to this panel. Any questions on the purpose of overcurrent protection coordination? I don't see anything in the chat.
We do have a generic question, Bill. The
Okay.
question that was first typed in is there any differences in the requirements for hospitals and SNFs? And that might be something we can answer now or hold off until the end.
We will take care of it in the next slide.
Perfect. Thank you, Bill.
Yeah. So let's look at the code requirements. For a type 1 essential electrical system, and a type 1 is a terminology used in NFPA 99, and it was added to the California Electrical Code in the 2019 code cycle. So this is your hospital essential electrical system. It's also used at SNFs with subacute beds. The code requirement for coordination is 517.31G. It was added to the California Electrical Code in 2016. Prior to 2016, there was still a coordination requirement. What the code said in 517.26 is the essential electrical system needs to meet the requirements of Article 700. In 2007, coordination was added to Article 700. I believe it was 700.28 at that point. So type 1, we have the requirement of 517G, 31G. For your type 2 essential electrical systems, they are also required to meet coordination requirements. Per the code, it is 517.26, which gets you to 700.32. So a SNF would be a type 2. It is required to coordinate. And this aligns with what you will find in NFPA 99, that essential electrical system coordination is required for type 1 and type 2 essential electrical systems. For those who are familiar with CMS, the coordination requirement was added to NFPA 99 in 2012. So projects that are required to meet the CMS requirements would be required to meet coordination. Some other coordination requirements that are applicable to healthcare facilities is elevator supplied by a common feeder, and we'll look at what that means in a slide down, a few slides down, and fire pumps in multi-campus style complexes. This is not a normal fire pump installation. This is where you have a campus distribution system and you're connecting a fire pump and you're building to this medium voltage equipment. We have 2 other requirements for coordination that we'll talk about, and that is the emergency system and legally required standby systems in Article 700 and 701. These are not used in hospitals. They're in the pen in case you're feeding a non-healthcare building from a cup and are required to have an emergency system for that building, but they are not applicable to a hospital or SNF. So let's look at 517.31G. What we have here is we do not have selective coordination. We have what's called coordination in the code. It only requires coordination from 0.1 second and above. You do not have to coordinate below 0.1 second, which is required in a selective coordination. So this makes coordination easier for your overcurrent protection devices. There are some exceptions. We'll look at those. And one note for the person who had the comment, HCI allows type 2 essential electrical systems to meet the 0.1 second coordination requirement, rather than the selective coordination requirements of 700.32. And we do this to align with the NFPA 99 requirements. So type 1, type 2, essential electrical systems need to coordinate from 0.1 to your overload. Let's look at what this means. It means from your branch circuits all the way to your normal supply, circuit breaker 5 and circuit breaker of 6 and 5 need to coordinate with 3 and 1 on your normal side. So coordination is required here. These devices, 1 and 3, are not part of the essential electrical system, so they do not need to coordinate. So your main breaker and your main switchboard and your feeder breaker to this transfer switch on the normal side do not need to coordinate. Now, on the emergency side, we require coordination all the way up to the generator main breaker. And the source of this figure on the right is from the 2020 National Electrical Code 700.32. So the right type of breaker is important. We have two examples. The one on the left has a 400 amp thermomagnetic breaker. You're seeing that we have overlap here between the upstream breakers and this 400 amp breaker. When we replace that 400 amp with an electronic trip unit, we get this system to coordinate. So you can see that in your plans, you need to specify the right type of breaker during plan review, or not during your plan design. And this is why we're asking for proof of coordination during plan review. So let's look at the exception to 517.31G. Exception 1 is for transformers. It says the primary and secondary overcurrent protection devices are not required to coordinate. So here's our primary breaker, here's our secondary breaker. There's one on each side. So these two do not need to coordinate. The purpose of that is if this opens, the secondary opens on a fault, or the primary opens on a fault, or both open during a fault, it's the same outage. The equipment downstream of the transformer will open. This, however, is not what this says, because it's talking about one overcurrent protection device on the second transformer secondary. So they're making it real clear that multiple feeders off the secondary would be required to coordinate. So if you have this situation, this exception is not in play, because a fault on this breaker, if this breaker and the primary are not coordinated, it will cause an outage for all this equipment below this point. So exception number 2, overcurrent protection of the same size in series. So this is in series, the 50 amp breaker in series with this 50 amp fuse down to this motor. These would not have to be coordinated. On this side here, we actually have a parallel circuit. So this is a series parallel combination. This would be required to coordinate, and with 50 amp fuses here, it's not going to coordinate with this 50. So coordination would be required for these fuses. On this side, you meet the exception. On the right, you do not. Same for this panel arrangement. I got a panel with a main 100 amp breaker. I got a feeder breaker of 100 amps. These two do not need to coordinate. They need to coordinate, both these would need to coordinate with the breakers in this panel. But as a pair, they're going to overlap in the curves, and that would be acceptable. This is not an example of in series. This 100 amp is not in series with this 100 amp breaker. These are all in parallel. So this does not meet exception 2. There's an outage over here, would trip that breaker, taking out power to all these other branch circuits. Let's look at the elevator supplied by a common feeder requirement. Here we have two elevators. They're supplied by this common feeder number 3 under the breaker number 3. So what is required to coordinate per the requirement is the disconnecting means. These are the disconnecting means. These are feeder breakers to the elevators, but they're not the disconnecting means. So the coordination requirement is a selective coordination requiring the full range from overload to the available fault current. This 7 breaker, most likely this disconnect device needs to coordinate with 3 and with 1 because they're both in on common feeders. But the 5 does not need to coordinate with 7 because they're in series, and the 5 does not need to selectively coordinate with 3 or 1. If this is powered by the essential electrical system, though, all overcurrent protection devices on the essential electrical system is required to coordinate at the 0.1 second coordination requirement. But selective coordination is still required, which is harder to meet for the machine disconnect switches, which are most likely fuses and should be easier to selectively coordinate. Fire pumps in multi-building campus style complexes, 695.3 G3. Again, if you look at 695.3, it will describe what a multi-campus style is. Most fire pumps are not. They're meeting the other requirements in 695.3. But if you have the situation, you must selectively coordinate, which is the harder requirement. Again, all fire pumps that are powered by the essential electrical systems need to meet the 0.1 coordination requirement. So this is a special case. If you have a multi-campus style complex, and you'll know if you do, you have a harder requirement to meet. And so that needs to be looked at from a selective coordination. Caesar, any questions?
Thank you for asking, Bill. We do have several questions. We have several hands that are raised, and we have several questions that are typed into the question section of that go-to toolbox. So I'm going to go ahead and call on the first, Andrew Holm. I see you have your hand raised. I'm going to go ahead and unmute you so you can unmute yourself. We'd like to hear from you. Andrew, are you there? All right. Looks like we can't get a hold of Andrew, so I'm going to go ahead and to the next hand that is raised. I'm going to go ahead and call on Thomas Shanks. I believe you have your hand raised. I'm going to go ahead and unmute you if you can unmute yourself. Thomas?
No, I didn't have my hand up. I appreciate it though.
Okay.
I guess it is up. I turned it off. I apologize.
No worries. Thank you, Thomas. All right, I'm going to scan through the list of names again, looking for more hands that are raised. I believe I saw some more. If not, I'll go over to the questions that are typed in. Jay, I see you have your hand raised. I'm going to go ahead and unmute you if you'd like to unmute yourself. Jay?
Hi, guys. I saw 2 breaker 400 amp breakers. One was a electric, one was a thermal, and I missed, came in a little bit late. Which one is recommended, or was one recommended?
Okay, so in this situation, the electronic trip meets the coordination for 0.1 coordination. So in this case, you'd want to specify an electronic trip. This is a real world situation where we had a coordination study come in where we had this overlap, and the engineer had to change to an electronic trip unit, and he was able to do so. The panel was designed to accept that electronic trip unit. But this is where specifying ahead of time during plan planning that is crucial, because you could get a panel that is not capable of accepting an electronic trip circuit breaker. And then you're looking at replacing the whole brand new panel to fix this coordination issue.
Great, thanks. Thanks for that, Bill. I'm gonna go ahead. We have one more hand that is raised. I'm gonna go ahead and unmute Brian. If you'd like to unmute yourself, Brian, we'd like to hear from you.
Yeah, actually, right on the same slide, and I had typed this question. So on the right-hand side, you still have, is there still a coordination issue between that red and green breaker example? Is there still overlap there that needs to be fixed?
This is great. This is a great question. I didn't include the transfer switch diagram, the schematic with this the single line diagram. These happen to be the normal side is red, and the green is the feeder from the emergency side. So this is a breaker that's downstream of the transfer switches is 400 amp. I believe these are 1200 amps, normal 1200 amp feeder, and a emergency side 1200 amp feeder. And so,
I got you.
yeah,
Yeah,
so,
because they both don't technically work together. They're on independent paths. They don't need to coordinate, obviously.
they don't have to coordinate, and I will make a note to fix that on this slide to explain that. Yeah, that's a good question. But this would be a good example of not coordinating if these were upstream and downstream breakers, but these happen not to be. Or this could be an example of two breakers in series, which are allowed to overlap, would be an example. These would be two 1200s, but in this case, this happens to be the normal and the emergency side feeders.
Great, thank you. Great question, Brian. Thank you for that. I'm gonna jump over to the typed in questions, Bill, and you might have to click back a couple of slides for this one. The question reads, is series rated OCP acceptable?
Is series rated OCPD? Okay.
So I could,
yeah, series.
I could take this one, Bill. So series rated is defined by or included in the literature of the manufacturers of a specific family of overcurrent protection devices. So for instance, if you have a 20 amp breaker, or let's say a 60 amp breaker that's rated for 10K AIC, and upstream of that you have a 100 amp breaker that's rated for 22K AIC, the manufacturers tested these breakers in series and determined that you will not have catastrophic failure of the 10,000 KAIC breaker if the available fault is less than 22,000 amps. So in effect, what the manufacturers, what you're allowed to do is buy a breaker that doesn't meet on its own the AIC rating that it might experience, but in tandem with an upstream breaker does meet that AIC. So that means that you're going to trip the upstream breaker and the downstream breaker is going to be safe. So the answer is no. Series listed breakers is a way to use breakers that by themselves don't meet the AIC that's available, but in tandem with an upstream breaker do. So by definition, that means the upstream breaker is going to trip first, and therefore it wouldn't be coordinated.
Great, Jamie, thank you for that. We have another question, Bill.
Cesar, I'd like to add on that.
Yeah.
Series rated breakers are unrelated to electrical coordination as well. But Jamie's explanation was correct, but that's a sizing of the AIC rating, basically your short circuit fault, available fault current rating, which does not come into play with coordination at 0.1 and above, because we don't look at the fault current at that point. So it's a unrelated topic to coordination.
All right, we have another question here. The question is, please clarify that although normal coordination isn't required under pin 70, but may still be required by the DPOR for design purposes.
Sure. Coordination of your normal side is good industry practice. I do want to say that for the elevator requirement, it's required whether you're on the normal side or this elevator is fed by the central electrical system. And the same is true for the fire pump requirement. This is on the normal side as well. So there are selective coordination requirements that are required for the normal side. But in addition to that, it's good industry practice to coordinate your breakers, even if there's not a code requirement for doing so. And you will have to come up with settings for your adjustable breakers on the normal side. And you would use the same approach you use for coordination on the normal side.
All right, thank you, Bill, for that. We have, well, this will be our last question for this section, then we'll move on to the next. Slide 13, define a set of breakers versus a tree of breakers with distribution.
Okay, so what they're talking about, a set of overcurrent protection devices, is this is showing a circuit breaker, but you could have fuses, and you would have a set of fuses. You'd have 3 fuses here, one for your A, B, and C phase, but they work to protect this one secondary feeder. That's where the term set of overcurrent protection devices is talking about. Where this here, if these were fuses, you'd have 3 fuses here, 3 fuses here, and 3 fuses here. 3 sets of overcurrent protection devices. So that's the difference between why they don't just say fuses, circuit breaker, and then fuses here. I guess you could have handle ties on a 3-pole breaker. So but what they are really addressing is one primary feeder, one secondary feeder. So the outage is the same if either one of these trip. Okay, so we'll move on to frequently asked questions. The first one.
Okay. I did see one more question from Stuart Kirkland. I don't know if it's been answered. Would that exception apply if the 50 amp fuse was smaller in size?
OSHPOD this is the code requirement. OSHPOD understands that this 50 amp fuse might be 45. We would allow this. We would not require coordination, even if this was a 50 amp breaker and your piece of equipment here had an MOCP of 45 and you put a 45 amp breaker. We are not going to require coordination, even if these are not the exact same size. These are in series. This motor shuts off if either one of these trips. The rest of the system up here continues to run. But the letter of the law in this requirement talks about the same size. I don't know why they did that, but we will not enforce it that strictly. But this is not the same as what's on the left. This meets the exception. This does not. That's the main point.
Thanks.
Okay, so we'll move on and we'll come back. I'm sure there'll be more questions and we can drill down some more. Pin 70 is new. Does a project currently in construction need to meet the applicable electrical coordination requirements? And the answer is yes. Even though Pin 70 is new, it's a policy intent notice, and the purpose of Pin 70 is a guide to industry to inform the industry of these coordination requirements that have been overlooked by some designers. It's to help the industry know what OSHPD's expectations are during plan review, so that as a plan reviewer, I can approve your plans. I can't approve plans that don't meet code. So Pin 70 was developed as a method that would dictate how OSHPD would accept your design during plan review, even though we all know that on big jobs in particular, where it's new build, you might have 4 or 5 different manufacturers specified, and you will not be able to do your final coordination study until construction. So it was in the TIO in 2013. Coordination, as we saw before, was introduced into the code in 2007. Pin 70 aligns with the HCI remodel can that requires all new elements of construction to comply with current code. And it also aligns with NFPA 99, which requires the modernized portion of an existing system to meet the current NFPA 99 installation requirements. So there's nothing new in Pin 70 as far as code requirements. It's mainly a document that tells us what you have to do during plan review to demonstrate that your system coordinates. So is coordination requirement for a 20 amp circuit breaker on the central electrical system? And the answer is yes. The reason why is a 20 amp circuit breaker might trip your upstream feeder circuit breaker, which would take the whole panel out of service. You'll find it in the handbook that it is talking about the 20 amp circuit breakers. And it was added to Article 700 because of lighting circuits. They did not want a fault on a lighting circuit taking out the remaining branch circuits from a panel. So it was actually introduced for 20 amp circuit breakers to the code. Is there a magic ratio? So coordination study is not required, and the answer is no. I wish there was. I have rule of thumbs when I was a designer, and I thought they worked, but they don't. They don't work, especially with your thermomagnetic type breakers. So here's an existing system that we had. We wanted to add a 30 amp breaker to this existing panel. We have I think it's 150 amp upstream breaker, 30 amp branch circuit. And you can see it's not coordinating. And this would be a ratio of 5 to 1, and it's not coordinating. So there's no magic ratio. In Pin 70, because I am old school, I made a comment about a blue pencil comment. A blue pencil goes back to the old days when we did plan review by hand. A red pencil was an enforceable comment. A blue pencil was a non-enforceable comment. It's just a FYI. So OSHPD will do a FYI comment if we see your ratio is less than 3 to 1. So you have a 20 amp branch circuit and a 60 amp main breaker. We're going to make a comment just as an FYI. It's a courtesy to you that you might be overlooking coordination. But coordination study is still required, and the system is required to coordinate at any ratio. Are SNFs required? And the answer is yes, and we talked about that. But the one thing we do at OSHPD is the SNF essential electrical systems are only required to coordinate from 0.1 second coordination instead of selective coordination. And we do this to align with NFPA 99, and also just makes common sense that the requirement for a type 2 should be the same as a type 1 and not more strict than a type 1. Can manufacturer coordination tables be used in lieu of time current curves? And the answer is yes. There's many ways to demonstrate coordination. And if you are using the same manufacturer, you can work with your manufacturer. They do have tables. And as you clearly indicate in your study, how your breakers are coordinating using this information, that is acceptable. So what needs to be in a coordination study? Well, the first thing is the engineer of record, and not the engineer that necessarily did the coordination study, but the actual engineer of record who is responsible for the design needs to stamp and sign the cover sheet of the electrical coordination study. And this is a CAC requirement, California Administrative Code. The AOR, he needs to sign the cover sheet, and that's again for the California Administrative Code requirement. We need some type of summary to help us in plan review that clearly identifies that all the overcurrent protection devices meets the applicable coordination requirements. If it's essential electrical systems, and a statement saying all the breakers shown in this report coordinate to 0.1 second or some statement like that. The study needs to show the manufacturer, the model number, current rating of the OCPD, and the settings for the breakers. This information can be in a table. It also can be listed on your time current curves. Again, time current curves and data from the manufacturers, a single line diagram, and for your elevators and your fire pumps required to selectively coordinate, we will need to see your available fault current. So we'll need fault current information. Can a coordination study be part of a power system study? Yes, of course. And on your bigger projects, you are going to do power system studies. You're going to do arc flash studies with it, coordination, short circuit, and you might have power flow studies. There's many things that go into a power system study. And you can just submit your power system study. It makes it harder for HCI to review, but that's our problem. HCI will review the coordination study and the short circuit study if you submit it. We do not require a short circuit study to come in the office for review, but if you submit it to us, then we will take a look and verify you have no short circuit issues. Your AIC ratings are correct and your equipment short circuit rating is correct. We will not evaluate arc flash studies. There's very limited code requirements for arc flash in the California Electrical Code. There's only one requirement for service equipment. But the remaining incident energy labels and calculations we will not be looking at. It's great practice. You should be doing it. OSHA tends to require it, but it's not a hard requirement. It's worded funny. But arc flash studies are something that should be done, but we will not evaluate it because there is not a requirement or limited requirements in the California Electrical Code for incident energy calculations, boundary conditions. And we won't evaluate any other studies in your power system study. Can a coordination study include time current curves for the normal system? We answered this before, yes. In fact, it's good practice to do it. Except for those special cases with the elevator and the fire pump, there are no other requirements for the normal system. HCI, help us out by making it clear on your time current curves what system the curves are for. That way we don't see a problem with your normal system curves and make a comment. It happens when we're reviewing by accident, and we don't want to delay you. Can your coordination study be part of your electrical plans? Yes, it can be. You can put your curves on your plans. And if you have a small project, this is pretty nice. Here in this situation, there's an upstream breaker. This is your feeder breaker, feed in a new piece of equipment. This is the fuse for the equipment, which is in series with the 30 amp breaker. And being it's so simple and you already know the manufacturer during design, you put all the equipment information here and your TCCs and a statement that it coordinates, and you're good. Questions?
Great, thank you, Bill. We do have some questions. We do have a couple of hands that are raised as well. So I'm going to go with the hands that are raised. I'm going to go ahead and unmute you so you can unmute yourself. Chris, I see you have your hand raised. I'm going to go ahead and unmute your mic. So please go ahead and unmute yourself.
Yeah, can you hear me?
Yes, I can.
Yes, we can.
Yeah, sorry, I tried to raise my hand. You answered my question through the
Perfect.
files.
Not a problem.
Is my hand down now?
It is. Thank you so much.
Okay. All right, thank you.
All right, thanks, Chris. All right, we have another hand raised. Arturo, I think you have your hand raised, but I don't think you have a mic, but I'll go ahead and try to unmute you. Arturo, can you hear us?
I can hear you. I don't know if you can hear me.
Yes, go ahead.
Okay, so I have two questions. You just mentioned that the coordination study could be put on the drawings, and that's exactly what we are doing here at our facility. We're having the engineers put this on the drawings. If it is on the drawings, as we just spoke, what is required on the TIO then?
At this point, it's still required to be put on the TIO, but we are evaluating that.
So who would be, if it's on the drawings, who would be listed on the TIO as, would it be the engineer, the electrician, you know, as far as?
The IOR needs to verify that the breaker settings are correct, and he should do that. The IOR should do that with the engineer record.
So that means that the IOR's name should be on the TIO?
Caesar, do you know that exact question?
I'm sorry, what was the question again? On the TIO?
Yeah.
As far as if the coordination study is on the drawings and still required to be on the TIO, whose name is put on the TIO at that point? Is it the IOR?
So on the TIO, you should identify the IOR to have that IOR verify, and then on that one specific column, and on the adjacent column, it would be the OSHPD field staff to concur with that.
Okay, that's okay. So it is the IOR that does, because we normally have to put somebody's name, whether it's, you know, an electrician or whoever, somebody, a professional that is going to verify the study. So it's going to be the IOR. That's fine. The second question I have is, you mentioned that sometimes the coordination study can't be done until the project is ongoing already. But if the engineer of record specifies a certain breaker that they already know the coordination study for, doesn't that mean that the coordination study could most of the time be done during design?
Correct, and we'll cover that in the next topics.
Okay.
Yes. If you know your breakers and what's being installed, you can finalize your final coordination study during plan review, and that'd be the best case. It does not have to happen after plan review, during your plan design phase. Best time to do the final coordination study is during design phase, but it's not practical in many cases.
I understand. When it's not, then it becomes an ACD, doesn't it?
We'll cover that. It'll become a deferred submittal. But we'll cover that in a minute.
All right. Thank you.
Mm-hmm.
That's all.
And if you have more questions, then after that, we can talk some more.
All right, we're going to jump over to some of the typed in questions, Bill. The first question that I see here that we'd like to ask is, a person asked about coordination of the normal side. If it is not required by code, but the IOR is requiring it, please confirm that the IOR does not have the authority to require a coordination study of the normal side if it is not required by code for the particular project.
Caesar, do you have an answer for that one?
So my initial response to that question would be, if it's not in code, then it's not going to be required or enforceable by the IOR or by the office. So as always, we refer to the code as minimum standards. I know this question is specific to the IOR, but if, for example, the design professional does require it and they identify it on the TIO, then that would be part of the essential requirement for the project. But in short, to answer your question, Amy, the IOR would not have the authority to enforce that if it is not required by the DPOR and it's not on the TIO. Next question. Go ahead, and the question is, are individual 20 amp one pole breakers within a panel board required to coordinate with the main breaker of the panel or the upstream sub-feed breaker if the panel is main lugs only?
Yeah, so we have some examples that I'll show you later, but the simple answer is yes. That single pole 20 amp breaker needs to coordinate with the upstream breaker. If the panel has a main breaker, it needs to coordinate with that. And I have some examples I'll show later, but it's going to also have to coordinate with the feeder breaker. So let's say we have a situation, we have a panel and it has 20 amp breakers in it, has a 100 amp main breaker and a 100 amp feeder breaker for that panel. Those 20 amp breakers need to coordinate with the 100 amp main breaker, and it also has to coordinate with the 100 amp feeder breaker upstream. So it has to coordinate with both, even though it's only a 20 amp breaker.
All right. The next question here is regarding manufacturer coordination tables. Many of these tables indicate coordination of just the instantaneous trips, not relevant to the 0.1 second coordination, and do not indicate coordination.
Yeah, so that's where I'm saying work with your manufacturer. If they have data and tables that are 4.1 coordination, and it would be not just the thermal, but it had to be the overload as well, we can accept that. So it's an option, but work with your manufacturer.
Question, Bill, can the electrical coordination be listed as a deferred approval?
Yes, we'll cover that in a minute.
All right. And we have a ton of questions, and we have about 2 minutes to go through this until we get to the next section of the presentation. So we'll try to go through these as quick as possible. Next question here is, sometime circuit breaker TCC curve has small overlaps with upstream circuit breakers. How HCI will deal with this? This situation means majority of the time breaker will coordinate, but in some cases it is a race between downstream and upstream.
The person understands coordination. We do not allow overlap of the curves. If they're touching, that's acceptable, because as we know that the curves are designed for the full tolerance of the breakers. So touching is okay, overlap is not.
All right, this will be the last question that we get to in this section. For electrical tenant improvement, if you're just changing or adding a breaker to a panel, the coordination is only required through the breaker directly upstream, or is a coordination required beyond that?
Just the breaker upstream.
Perfect. All right, Bill, I believe we're at our 10-minute threshold for this section, so we'd like to continue. If we don't get to these, if your question that was typed in, we'll try to get to it if we have some time at the end of the presentation, so hang tight.
Yep. Okay, so OSHPD PIN 70 policy, all new and repurposed existing OCPDs must coordinate with the new and existing electrical system as required by the code. The electrical plans must demonstrate that the system coordinates during plan review, and we'll talk about that. And a final coordination study demonstrating code compliance is required to be produced during plan review phase or during construction phase as a deferred submittal. And then if you have changes to your electrical system during design that affect coordination study, you need to resubmit your coordination study with your amended documents as an ACD. So the procedure that OSHPD is going to use for plan review is we have 3 options for demonstrating coordination during plan review. Option 1 is to provide the final coordination study. You already know your breakers and their settings, or the breakers that you're going to install, the type. So you know what the TCC curves are and their settings, and you provide the coordination study either on the plans or as a separate coordination study. During plan review, we will stamp and approve that coordination study. Option 2 is a preliminary coordination study demonstrating that the new OCPDs shown in the plans and specification will meet the coordination requirements. So this is not your full-blown coordination study, but you're going to do a partial study. It might just be for one particular manufacturer, but you're going to show us that you have a coordination solution with the understanding that during design, other components might be used instead. This preliminary coordination study could be done with manufacturer A. It turns out you install manufacturer B in the field, and you finalize your coordination study with your manufacturer B design. The third option is that you provide a letter or note on the electrical plans signed by the engineer of record stating the essential electrical system has been evaluated for coordination and the central electrical system will meet the coordination requirements of Article 517. You need to identify OCPD requirements requiring electrical coordination on your plans. So we need to know the scope of your coordination on your plan. So you need to make it clear. You can use sheet notes saying all the breakers in new panel XYZ and the feeder breaker, the 100 amp feeder breaker will meet coordination, will be part of the coordination study. You can use no call outs that you can use. You can use boundary lines on your single line diagram. You can list the equipment. We need some indication of what is going to be part of your electrical coordination. So we're not guessing during plan review. And then your coordination study that comes later will clearly match what you're saying is going to be in your coordination study. And when a final coordination study is to be submitted during construction phase, electrical coordination study shall be listed as a deferred approval on the project cover sheet during plan review. So front page, there's usually a section for deferred submittals, list electrical coordination study. Here's an example of a note that you could put on your plans. Again, the purpose of the note is for you to acknowledge that you have investigated coordination during design, you have specified the right type of breakers, and that you're just waiting till the construction phase to produce the actual coordination study. But you have already looked at it, and that's what this statement is. It's modeled after the statement that we have in PIN 38, where you are verifying that you have looked at the electrical loads being added to the system at level 2, and for PIN 38, it's the same idea. It's you acknowledging that you have verified coordination, and therefore we can go ahead and move forward during plan review to construction. We talked about this earlier. What is the scope of electrical coordination? So we know it's all the way from your branch circuits, even your 20 amp single pole breakers, all the way up to your generator breaker. And it's all the way up to your normal side, with the exception that your normal side feeder and main breaker do not need to coordinate because they're not part of the essential electrical system. For existing work, we have here, we're adding a new panel. So the breakers in the new panel need to coordinate. And the feeder breaker needs to coordinate with the existing panel that it's connected to, the feeder breaker for that. You're replacing a piece of equipment, an MCC. All the breakers inside the MCC need to coordinate with the existing systems downstream. So we got a breaker 5B feeding this distribution panel. It needs to coordinate with 6, but we're not going to look at anything below 6. So this existing panel, we will not be requiring you to validate coordination below that point, because this is the existing system and it's outside of the scope for the remodel can. This feeder breaker here, it will also need to coordinate with the existing supply feeders for this replacement panel. So you have to bring this new switchboard or panel up to current code, but it's limited to just the new replacement. So we have a piece of the utilization equipment that we're replacing, a new chiller perhaps, and it's the same type of equipment, and then we're going to reconnect it to the same panel, to the same OCPD, or we're going to connect it to the same panel, but we're going to reduce the size. We do not require coordination to be evaluated. We want you to replace old equipment with new equipment, but we will require coordination to be evaluated if you have to go larger with the OCPD, supplying your utilized equipment, or if you decide you need to feed it from a different panel. So, replacement of essential electrical system, individual OCPDs. You have a bad breaker in a panel due to age, you can replace it. We're not going to require coordination to be verified. You're replacing it with the same, with the same size and the same rating, same type of breaker. We move forward. We want you to replace bad equipment. Optional loads. The code allows you to do an optional branch. What we are asking is you coordinate your normal side and your emergency side. Our logic here is that we don't want anything on your optional affecting the emergency breaker on the generator or the main breaker on your normal side. So it's a little different than the essential electrical system, but we are just not going to look at coordination at this point. You can choose to fully coordinate this essential electrical, this optional, and treat it like your other essential systems, but we're not going to require it. Legally required standby systems, like I talked about before, don't worry about them if you're working on healthcare facilities. The requirements are not the selective coordination. For healthcare facilities, it's 0.1. Second coordination is the requirement. All right. Questions?
All right, we do have a couple of questions here. So we'd like to go ahead and call on you, Jose. I believe you have your hand up and it's been up for a while. So Jose, if you can unmute yourself, we'd like to go ahead and unmute you so we can hear from you. Jose, you there? All right, I'm going to go ahead and put your hand down. And if you do have a question again, feel free to raise your hand back up again. We're going to jump over to some of the typed in questions. Bill, this question is for you. When adding a new OCP on an existing fully coordinated system for new equipment, how many levels of coordination must be shown on the reports for the new installation? Will it be all the way back to the service main, up to the nearest OCP, or some level in between the two?
Okay, so you have a new system that's fully coordinated, or at least 0.1 coordinated, meets the coordination requirements. You're adding a new breaker to a panel. You would only have to show coordination for that new breaker and the device directly upstream. And if that is a branch circuit, that's as far as you have to coordinate. If this is a feeder to a new panel downstream, you'd have to show all the new devices coordinate. But only the limitation is, let's see. Here's your example here. There's our new breaker. It's right here. This whole system is coordinated, or it's not. It could be an old system that was put in prior to 2007 code. It doesn't coordinate. All we're looking at is here's our new panel. There's our breaker. And that's as far as we're going to take coordination. That's as far as you have to demonstrate it. If this is for an ACD, and you're asking me, do you have to resubmit the whole coordination study with just that correction? No, you could just submit the one page.
Right, thanks, Bill. We do have another hand that is raised. Mike, I see your hand is raised. I'm going to go ahead and unmute you. If you could unmute yourself, Mike.
Yeah, so question about replacing the old equipment. You say you don't need coordination because you want to replace the old one, but how about renovation? So if you have to relocate a panel or gear to a different location, would that still apply? Because you're not adding an additional load. Would the coordination required for relocation?
Yeah, so utilized equipment is what I was talking about, as opposed to electrical equipment. And but as far as relocation of an existing panel, you can move an existing panel without being required to coordinate. I think I covered that in the pen, but Mike, do me a favor. So let's not take that answer yet. Ask me at the end of the presentation. I believe I have a example that covers it.
Perfect. Thank you, Bill. Thank you for that, Mike. Peter, we do have your hand raised. I'm going to go ahead and unmute you so you can unmute yourself, Peter.
Hi. So on the overcorrect device on that last slide, if you go back to that, I saw that the breakers 6, 7, 8 are new.
Yes.
And circuit breaker 5 is existing. So if
Correct.
circuit breaker 5 is thermal mag and it needs to be replaced with electronic trip, does that have a waterfall effect where you have to replace breaker 4 as well, or are you just replacing 5 to?
No, it's a waterfall effect.
Okay, so it does keep going down the line that you have to keep replacing until they're all coordinated.
Right. That's why you have to look at this during, design.
Okay. Thank you.
Yep. Good question. Thank you.
Yeah, good question. Bill, I have another good question for you. This question states, newbie to coordination studies. Question, why is it okay for the instantaneous sections to overlap?
It's not.
All right, perfect. And that's a great question. Just to point something out, for those of us who are here, if you're new to the coordination study topic, feel free to ask a question, ask away. Your question is a great question and it might be helping others as well. So go ahead, Bill.
Yeah, so if I could just spend a second on that. So this is your overload This is your thermal. Your no overlap in either section. Where you're seeing overlap on these curves, like in this situation, these are, like I was talking about at one point, these are either devices in series, or in this case, they're the normal and the equipment side feeders. And this manufacturer decided to show them the TCCs on the same curve, which is acceptable. It's why it's a little tricky looking at these curves, because some overlap is okay and some overlap is not. So this is not okay. In this case, looking at the single line diagram, you go, okay, these guys are allowed to be overlapped because they're from separate feeders on a transfer switch, your normal and emergency side. And it is why coordination studies take a little time to review.
Bill, I think this question might have been referring to faults that trip before a tenth of a second.
If it's the 10th of a second, this here is a understanding that most faults are not bolted faults where you're going to have your full available fault current. And so this is a compromise that came up with an NFPA 99 to not require full coordination, because full coordination of an essential electrical system used in a hospital would be a challenging feat with how complicated our systems are. And so this is a compromise of true coordination of breakers. So we're going to allow overlap, and it's done with the idea that if you had a bolted fault short, we're going to take the risk that you're going to take down more than just the localized equipment. And so it's a trade-off. It's a trade-off in design.
And just to be clear, we're just adopting the national standard. So in this case, that's what how the NEC is written, and we take no exception to that allowance.
Yeah. Thank you, Jamie. That was a good point.
All right, next question we have is, does HCI consider using fuse in lieu of circuit breaker in order to provide proper coordination? This will create more unsafe conditions for patient in hospital in order to restore power due to require fuse replacement.
Yeah, well, the code allows you to use fuses. And so we take no exception to using fuses instead of breakers for coordination. We have a requirement in the code, like Jamie said, it's a national requirement, it's not California. And there are more than one way to meet the coordination requirements. With the 0.1 coordination requirement, it's less of an issue. It's easier to coordinate with breakers than if you had to do full coordination. But OSHPA cannot stop you from using fuses. And you're the engineer of record, it's your design. We require you to meet minimum code.
All right, and this will be the last question for this section. The question reads, does coordination study require while backfeeding a distribution panel? For instance, do we need to provide a 250 amp breaker is coordinated with the 400 amp main breaker with backfeed situation, which the 250 amp is used to feed panel temporarily?
So you're backfeeding through a 250, a 400 amp upstream. If the person wants to unmute themselves and
yeah, let me find the person in the list of names here. So bear with me.
well, Caesar,
I could maybe, yeah.
I think the best way to approach this one, Jamie, because it's a little unclear, is go ahead and submit that question to OSHPA, because it's an interesting, it's a little different than what we're talking about.
Yeah, my general thought is that if you're backfeeding, then you're opening the main breaker and you're using that as a temporary power flow, in which case you wouldn't have to coordinate with the breaker that's disabled.
Yeah, I would tend to agree, but there has to be more to it than that.
Yeah.
Great. All right.
Submit
So
that
Bill, if you'd like to
question, you can
move
answer.
on to the next section.
Yeah. Trying to remember where I was at. I think I'm on an example. Okay, so we talked about this quite a bit, but here's an example. We have a new panel that we're installing, panel CL3. No, I'm installing a new breaker in CL3, excuse me. I got a new 40 amp breaker I'm installing. Got an existing 100 amp feeder breaker. I have existing 20, 30, and 50 amp breakers. What needs to be on the coordination study? Curves for the 40, coordinating with the 100. We do not need to see anything above that, so you do not have to show the 100 with the 400. So you could just limit it to that work right there. For example B, we're adding a new panel. New panel is EH5. It's being fed from panel EH4 through a new 200 amp feeder breaker. The panel itself has a main breaker, and we have a 20, 30, 60, and 100 amp. Coordination study is going to need to show coordination of the 20, 30, 60, and 100 with the 200 main breaker and with the 200 amp feeder breaker. And the coordination study is going to need to show coordination of the 200s with the 400 amp main breaker. Spare circuit breakers used to connect new electrical equipment. So you have in a panel that has a 20 amp breaker spare, and you're connecting new equipment. And so instead of using a new breaker, you're going to use the spare breaker that's been sitting there for a while. We're going to treat that spare breaker as if it's a new circuit breaker and treat it the same as example A and B. So in example A, you had if this 40 amp was a spare 40 amp breaker in this panel, we're going to need to see coordination of that because you're adding new equipment. And so the new equipment needs to meet current code. Replacement in kind, we talked about this for utilization equipment. Again, if you're replacing utilization equipment and you're connecting to the same existing circuit and the OCP remains unchanged, we don't require coordination. You have to reduce the size of the overcurrent protection device, still connected to the same panel. You do not have to demonstrate coordination. But if you're increasing the size of the OCPD or you're connecting it to a new source of power, then you have to coordinate. Relocation, here it is. I think Mike had a question on this. Relocation of electrical equipment or utilized equipment. Coordination will not be required to be evaluated when existing equipment is relocated and reconnected to the same OCPD. So you're moving a panel because it's in the wrong location. You do not have to demonstrate coordination. And that aligns with the remodel can. You're replacing medical equipment. The new OCPDs installed need to meet the coordination requirements. Here's our elevator disconnecting means. You're replacing a elevator disconnecting means. You need to demonstrate, and it's fed from a common feeder as described in 620.62. The new elevator disconnecting mean must selectively coordinate with other supply side OCPDs. Fire pumps, we talked about that. We won't spend much time on that other than this requirement again in 695.3 is only for multi-campus complexes. But fire pumps are required to be connected to the central electrical system through a listed fire pump transfer switch, and is required to meet the 0.1 second coordination requirements. And that's for all fire pump installations. And I guess I got ahead of myself. That's what this slide says. Okay, questions?
All right, we do have a couple of hands that are raised. Jose, I'd like to go ahead and call on you again. I believe we had some technical difficulties before. So Jose, if you'd like to unmute yourself, we'd like to hear from you. Jose? All right, we'll try again later. We do have another hand raised from Justin. Justin, go ahead and unmute yourself as I've unmuted you. We'd like to hear from you.
Yeah, I had it in the chat as well, so apologies for a double. I wanted to have you guys speak to adding, let's say, like receptacles to an existing circuit with receptacles. So
Right.
let's say, circuit with 20 amp circuit, you got a couple receptacles on the circuit, you want to add another receptacle.
Yeah, so you're adding receptacles to an existing branch circuit. It's an existing branch circuit. You're not replacing the OCPD. You're not replacing the breaker. You can change that.
Okay. So
you can add it. There is no coordination requirement to be evaluated because it's an existing circuit.
Great, thank you.
But if you were to decide that you exceeded the load capacity of that circuit and you decide I got to add another breaker for some new breakers, then I'm going to require coordination because you have introduced a new OCPD.
Sure, understood. Thank you.
I think a lot of people will be adding breakers to receptacles to existing circuits.
Yeah.
Yep.
All right.
Great. Thank you, Justin, for that question, and thank you for raising your hand. Juan, we see you have your hand raised. We'll go ahead and unmute yourself. We'd like to hear from you.
Jose just asked the exact same question I did, so I'm okay. Thank you.
And so that would apply also to lighting circuits. So you're adding new lights to an existing branch circuit. Again, no coordination is required. You're replacing light fixtures to an existing system. That's utilized equipment. You can replace those light fixtures. We're not going to evaluate coordination.
All right, and I believe you just answered a couple of questions that were typed into the question section of the chat there. So we do have another question that says, does the coordination study require backfeeding a distribution panel? No, we already asked that. Sorry about that. Is a coordination study required for temporary equipment and service for 730-180 days? Reference CAN 2108.
The generator, your temporary generator, will need to coordinate with the existing system. If the temporary generator has a breaker that matches the same size as the permanent generator, then we will not require to look at coordination, and that's covered in the PIN. But if you were to add some temporary equipment, the temporary equipment needs to coordinate. So look at the PIN. If you have more questions, I guess you can unmute yourself and we can talk about it more.
Yeah, if you'd like to have an open discussion, go ahead and raise your hand. We can definitely call on you so you can unmute yourself and we can unmute you on our end. So gonna go through the list of hands real quick. Eric, I believe you have your hand raised. I'm gonna go ahead and unmute you so we can hear from you. Eric?
Yeah, hi, thanks. I was just gonna elaborate briefly on what the last person said, which is, adding new loads to existing circuits. It sounds like a good design practice may be, and see if you guys agree with this, would be instead of, only putting in the breakers you need for your project, maybe think about the next guy and add spare 20 amp breakers or whatever you might anticipate the load types for that panel to be. We're doing a lot of panels with that are designated as mechanical or plug load or lighting load panels, anticipate what those future needs might be and get those breakers in that current design. Does that sound like a good approach?
It's a great approach as long as those new 20 amp breaker spares coordinate, or any of your spare breakers. And so this is a good point. You have a panel and it's a new panel and you have spare breakers in there, and they need to be part of your coordination study. So you have a mix of breakers, and you decide you're going to add some spare 30 amp breakers, and there's no 30 amp breakers that are part of your curves, then you're going to need to show those spare breakers as well. So you're going to have to provide a curve for that 30 amp breaker. But yes, spare breakers are great, and as long as they coordinate. But just because there is a spare breaker in a panel, you're going to need to, and you want to use it, you're going to need to evaluate that spare breaker for a new piece of load that you're connecting to that panel. So just because there's a spare, don't assume it coordinates, is my point. A lot of panels are older and they don't coordinate, but you have to meet coordination on your new loads.
All right, we do have another hand raised, and we'll get on to another typed in question. Mr. Mike Mars, I believe you have your hand raised. I'd like to go ahead and unmute you so you can unmute yourself. Go ahead and unmute yourself so we can hear from you.
Okay.
Hello, Mike.
Hi. This is related to coordination study testing. We haven't really talked much about that as far as the TIO, what it requires. And so my question is you have a third party usually from the contractor that goes in and does adjustments on adjustable breakers, and then they're tested accordingly to make sure that the lead, lag, and trip settings are correct and observed by the IOR. My question is if that can be done off-site, or if it needs to be done after the installations or the equipment's installed.
Now,
and then I have another question after that.
Yeah, okay, so let's make sure we have a hard requirement in the code for testing of the ground fault settings of breakers. I think it's 517.20 for your ground fault settings on your main panel. That's a hard requirement, and it's a hard testing requirement. For your other breakers, you won't find that same testing requirement in 517.31G or in Article 700.
Okay, I'm just reading it right out of the TIO here under test.
Right.
So, but I'm assuming that's just the coordination study itself. Is that correct?
And verifying that the settings in the field match the coordination study.
Okay. And only that, but it's
there's no requirement for a NETA test on that breaker. I'm a big believer in NETA testing of equipment and of settings of breakers. They're typically, like you said, not done with the equipment installed in the switchboard, but usually done off-site or done in a separate area on the construction site, and they connect it to their breaker simulator and go through the trips to verify your breaker is performing as designed. And but that requirement is not what the TIO is, why it's on the TIO. The TIO is just verifying that the breakers actually match the coordination study. So they're the right manufacturer, the right part number. Because as you know, Mike, you're an inspector. Things don't always get installed like they should get installed.
Yeah, great case in point. And one of the things I see in the field is that a lot of the equipment that arrives does not match the approved submittals. Therefore, you could have issues with different equipment, which is going to affect the coordination study overall. And as you said in the beginning, you know, it may result in having to get new overcurrent protection devices, if not the whole panel. So it's really important to make sure that equipment is correct especially when it comes off the truck.
Yep. Completely agree.
Yeah. Mike, just the other, and I think it's been said, but then the other piece of that is that then it should be verified that the settings that are recommended in the study are actually, the breakers in the field are adjusted to match those settings.
Yep. And then also in the TIO under responsible approved agency, would that be the contract or IOR? I just want to clarify that.
Mike, you're the expert on this. What do you think it should be?
Well, I think the person that's actually dialing in those settings, the IOR, is my take.
Mike, we missed you a little bit, but I think you said
Would be a
the guy-
third part of the contract.
So Mike, you're cutting in and out, but I believe what you're trying to say is that the
Pardon me?
Mike, you were cutting in and out, but I believe, correct me if I'm wrong, but I believe what you were trying to say is that the EEOR, or the electrical engineer in charge, should be listed as a responsible in charge or a approved third-party listed testing agency, and the IOR by default verifies those settings. Is that correct, Mike? Are you still there? All right. Okay. I believe we lost Mike. So we'll go ahead and we need to keep going. So we have one more raised hand. Bill, if you don't mind, I'd like to go ahead and call on this individual.
Sure, please.
Vincent, I see you have your hand raised. I'm going to go ahead and unmute you. You can unmute yourself, Vincent.
Hello. So earlier about the available fault current, I was wondering if we have to show that on our TCCs.
No, not for point one. Not for point one coordination, because that's the available fault current will be below point one. That's where you have the boot, if you will, and we don't need to see that. If it's for a fire pump or an elevator, then yes, because they require selective coordination.
All right.
Got it. Thank you.
Thank you, Vincent, for that. All right, Bill, if you'd like to continue on to the next section of the presentation.
So OSHPD is just new to reviewing coordination studies in the office. And so there's been some hiccups. So let's talk about submitting electrical coordination studies. Well, the first thing is fix all your problems before submitting coordination study for approval. OSHPD does not need to see your iteration. Coordination studies tend to require iterations. You make adjustments, tweaks, and with the software they have today, it's fairly easy. Back when I was young and you had to do it on paper, it was challenging. But this is an example of a coordination study we had where the third party that did the coordination study identified problems and actually came up with solutions for the engineer. But they submitted this coordination study to us and it had problems, and the TCC showed problems because they weren't corrected. So work with your third parties, or if you're doing it yourself, finalize your coordination study before you submit it to OSHPD. We just need to see the correct coordination study, not your interim coordination studies. And you can submit your revised plans with your coordination study. One big problem that occurs that I see over and over again is the breaker sizes and your fuse sizes shown in your coordination study do not match the approved plans. So we will compare your single line diagram in the approved plans and your panel schedules with the information shown in your coordination studies. So make sure they match. One other big hiccup that we have is the engineer record needs to stamp and sign the cover sheet of the coordination study, taking ownership of the information provided. We understand a third-party engineer might do this work, and he'll also stamp the coordination study because he developed it, but the cover sheet needs to be stamped by the engineer of record, and the architect of record needs to sign it, just like you would do for a specification or other type of report. So, do you use a DSI or do you use an ACD? So we're talking about a brand new project. You have it in plan review. You are electing to put a note on the plan saying, yes, I verified that the system coordinates, but it's going to be, the final components are going to be selected during design. And you're going to indicate on the plans that there's going to be a deferred approval. And later you're going to submit your coordination study during construction as a DSI. If there's changes after you submit the DSI and get it approved, then you need to submit an ACT with your changes. And this is after you have first got your coordination study approved. So there's changes to your coordination study, then you use an ACD. You don't use a DSI at that point. Finally, for projects that are currently in construction and you never submitted a coordination study to the office, you don't use a DSI because we didn't require it during plan review, but we require your coordination study. Use an ACD to submit that to the office. Again, if you have changes based on the coordination study, you can submit those with the ACD that has the coordination study. Another option though is you did an ACD that changed all your single line diagrams and your panel schedule, and now you want to submit an ACD for the coordination study, you can do that as well. But we will be comparing your approved plans with the information provided in the coordination study. This is new for Oshpod.
Hey, there are some panel reads for the CT room B.
Yes.
Rad CT.
Caesar, can you mute that?
Mesa net add.
Hello, I'm sorry. I believe somebody is on the presentation. Can you please mute yourselves? We'd like to, if you're not speaking directly to the presentation. Thank you.
Okay, this is new for submitting a coordination study to the office. What was happening is when you uploaded your coordination study, it got stuck in our plan review system, Acela. E-service portal is what you guys see it as. And it was never started in plan review. So again, Oshpod apologized if your coordination study was delayed. We expedite coordination studies right now. In fact, I help out with that. So when you're uploading your coordination study, you will find a new document type called coordination study. So you select that. And you have a description and first submittal. This is normal for people who upload. I don't upload projects, but for people who do, this should look familiar. But your type is now electrical coordination study. You have your first submittal. And this will help us review your plans and they won't get lost in the system. When you submit a coordination study to HCI and you don't have plans with it, we create a dummy plan to put your comments. So here's my comments about your coordination study. This is just a placeholder. It's a dummy plan placeholder. You do not have to submit that back to the office. You just submit your new revised coordination study with all your problems corrected. If electrical plans are not being revised on the coordination study, we're asking you to please consider uploading the latest approved single line diagram and essential system panel schedules as reference only documents. Otherwise, we have to dig through your ACDs to find the latest single line diagram and essential electrical system panel schedules, and it delays us on reviewing your coordination study. So do us a favor, which will help you by submitting a reference, the latest drawings with your coordination study. And like I said earlier, this placeholder does not have to be returned on back check. Oops, I went the wrong way. Yeah. You just need to, when you're submitting your back check, we just need the Excel file response to comment. Okay, we have some time, so questions?
Yeah, we are a little past the hour-and-a-half mark on the presentation, but you're more than welcome to stick around. We're going to go ahead and answer some of these questions. We do have some more hands that are raised, so feel free to do that. If you do have a specific question about a specific project, which we did receive some specific questions in the question box, send them over to the email address that I gave earlier, which is regsunit@hchi.ca.gov. That's regsunit@hchi.ca.gov. So with that being said, I do see Sean, you have your hand raised. I'm going to go ahead and unmute you so you can unmute yourself, Sean. Sean, I see you're unmuted. If you'd like to ask a question, go ahead. If not, we can move on to the next. All right, I'll go ahead and move on to the next. Let's see here. Looking through the list name, Mike, I believe you have your hand raised again, Mr. Mike Mars. I'm going to go ahead and unmute you if you'd like to unmute yourself.
Okay, can you hear me?
Yes, we can hear you.
Okay, I'm just going to try to carry on what I was trying to ask earlier, in that the TIO, as far as individual responsible, would be a third party listed and is witnessed by the IOR. To me, that would make more sense, but I wanted to get your thoughts on that, Bill.
Yeah, I think that Caesar thought that was appropriate, and
okay.
Yep.
And one last question. You mentioned it earlier in the program. What is the differences as far as electrical coordination with skilled nursing versus subacute, or is there any differences?
There is no difference. They
okay.
both require 0.1. As you know, a subacute SNF would have the 3-branch
yes.
central electrical system, but the requirement is the same.
Okay, thank you.
Yes, sir.
Caesar, I'd like to take one question that's in a generic sense. It's talking about mixed manufacturers of overcurrent protection devices, and I think it's a good question because it brings up a point. The contract documents typically are going to be generic, certainly or listing multiple manufacturers to keep the prices competitive. The requirement to meet code is always embedded in each of the projects. So if there's an existing facility that has used, for instance, Square D throughout, and then a new project is making a modification, that new project can still be open bid, but the contractors are going to be responsible for providing the coordination or products that coordinate. And the point I want to make here is that the best time to see that you have a project that can meet selective coordination is during design. That's why we'll make comments sometimes, as Bill said, for your information, or blue pencil only, that we see overcurrent protection devices that are not sufficient ratio, that most manufacturers could provide those to be coordinatable. The second best time, and what's also critical, is that and the master specs do require that a coordination study that demonstrates code compliance should be submitted and approved prior to ordering of the equipment. So what we're really trying to do is move this challenge of coordinating essential overcurrent protection devices into the design side before the procurement begins. So multiple manufacturers can coordinate. It's just that each breaker has its own characteristics, would be put into the software program to demonstrate coordination, and that can take place. If you have breakers that are essentially of the same size, a 60 amp breaker with an 80 amp breaker, the coordination is not going to be achievable by any manufacturer. But if you have ratios in the neighborhood of 3 to 1, your chances are good, but you still need to have the coordination study complete, and we recommend that take place during design, or if not design, during construction before the product is procured. So I hope that helps.
Thank you, Jamie. That was excellent.
Great. Thank you for the clarification, Bill and Jamie. That that helps a lot. I'm going to go ahead and keep mentioning names here, so you can unmute yourself. Michael, I see you have your hand up. I'm going to go ahead and unmute you. If you're still there, go ahead and unmute yourself. We'd like to hear from you. Michael?
Yes. Can you hear me?
We can hear you.
Okay. Just a quick question. So we're working with a lot of older hospital facilities that have older equipment, and a lot of the breakers don't even have trip curves available any longer. How do you address that? Like coordinating with the new stuff.
Yeah, that's a hard situation. You need to be working with your I'm trying to think of the companies, but your simulation software people. They usually can come up with curves that should match, or will be your best engineering guess of what that curve is. Because most of them have pretty extensive libraries, even for older devices. But you need to demonstrate compliance.
So that may require replacing some of the existing equipment.
It's possible if you have worked with them and they can't even give you their best guess of what that breaker curves are.
Okay, thank you.
Yeah, I'm drawing a blank at the companies that make it. SKM, I think, is one of them.
Yeah.
Great. Thank you, Michael. Great question. We do have some more. Bill and Jamie, if you don't mind, I'll like that you continue calling on these individuals. Manuel, go ahead and unmute yourself. We'd like to hear from you.
I lag in late, so I just like to know how we can get a copy of this PowerPoint presentation.
Sure, I can go ahead and answer that. So if you go to the Go To Toolbox under the handout section,
can you hear me?
Yes.
Hello.
Yes. Can we hear you? We can hear you.
Hello.
Yes.
Yeah, we can hear you. If you go to the handout section of the Go To Toolbox there's two documents. One is a presentation and one is the actual pin that you can download for your use, and it's in PDF format. So go ahead and unload.
Is anybody can hear me?
Yes, we can hear you.
I just want to know how we can get this PowerPoint presentation, a copy of this PowerPoint presentation.
Manuel, if you like, you can go ahead and email us. We'd be happy to send that over your way, or you can go to the handout section of the Go To Toolbox and download them yourselves from the presentation. So send us an email over to the regs unit at hchi.ca.gov email, and we'd be happy to send that, or you can go ahead and download. I'm going to go ahead and mute you. We have a couple more hands. Justin, I'd like to hear from you. I'm going to go ahead and put your hand down and unmute you so you can unmute yourself, Justin.
My apologies. It looks like I accidentally raised my hand. My apologies.
Okay, no worries. Thank you for doing that. Jose, I believe you have your hand up. I'd like to go ahead and unmute you if you'd like to unmute yourself. Okay, I'll go ahead and put your hand down. I believe that's the end. Oh, I'm sorry. We have one more hand raised. Derek, I believe you have your hand up. I'm going to go ahead and unmute you. Derek, if you're still there, go ahead and unmute yourself.
Okay. Yes, thank you. So going back to required signatures for CAC 7-115, it says the EEOR shall stamp and sign the cover sheet of the electrical coordination study. So if this is being submitted as a deferred submittal, deferred approval, you know, usually that comes through the contract as a submittal. Is that saying that the stamp can be the submittal review stamp and the engineer of record should sign that? Or do you want to see their registered engineer stamp?
Here's what we need. We need you to, as the EEOR, we need you to stamp with your seal. We need you to seal and sign the document.
Okay, got it.
And
Thank
I understand you're going to have your submittal stamp signed there as well, but we need you to seal and stamp it. Otherwise, we can't approve the document. And you're going to need that approval. We're going to need the OSHPD approval stamp on your coordination study.
Okay, understood. Thank you.
Yep. And again, we also understand that a third party will probably also have his stamp on it because he's the one that actually did the study for you. But again, you're the engineer of record, and it's you take ownership of that, of his recommendations, basically. And what occurs is, well, it's just a CAC. It's probably easy to say that, but your third party person is not. He's going to give you options and let you decide how you're going to fix your system. He's not going to take ownership of the design itself.
Mm-hmm. Okay, thank you.
You're welcome.
All right, Bill, I believe that's it. We do have a couple more questions, but we are at about an hour and 48 minutes into the presentation. Is there anything else that you'd like to add, Bill or Jamie?
Jamie, do you have something?
No, I just wanted to reiterate, we're trying to help. One of the reasons that the PIN was announced was because of feedback from the field that there were challenges at the very end of the project. So we're trying to move the coordination efforts up to design and early construction to benefit everyone.
Great, thank you for that, Jamie. So with that being said, we'd like to remind you that the presentation itself and the PIN itself are available for download under the handout section of the go-to toolbox there. So if you haven't done so, feel free to do that and have that access, or you can go ahead and access the PIN on our website. Also on our website, you can access previous presentations such as CAN 211B, accessibility for healthcare facilities, OSHPD 3 clinics, what, where, and how, temporary structures, CAN 2108, engineering judgments, CAN 2-703.3, and much, much more. And also, if you do have a specific question or feel that you have an additional question, feel free to send us an email over to regsunit@hchi.ca.gov. That's regsunit@hchi.ca.gov. If you haven't done so already, and if you'd like to get future notifications of future presentations that we're going to have, or documents such as tips of the day or notifications of future presentations, go ahead and register on our listserv at www.hchi.ca.gov. on the upper right-hand corner. Click subscribe and fill in the required information and let us know what you'd like to hear about. And we'd be happy to send those to you as we come up with future presentations and documents. So again, thank you for being here. It's been a pleasure being here with all of you today. Thank you for what you do and for doing your part in providing access to safe, quality healthcare environments throughout the state of California. Until next time, thank you.